Hello. Ayan. So, good afternoon guys, no? Sorry wala ta kaklase early in the morning kay due to uh, webinars. So, for today we will discuss about Stadia and Tacheometry. So, when we say tacheometry, it is the procedure of obtaining horizontal distances and differences in elevation based on the optical geometry of the instrument. Okay. So this rapid and indirect method of measurement uses subtended intervals and angles observed with an instrument, so such as a transit or theodolite, total station on a graduated rod or scale. So in tacheometry, we can measure the vertical angles, the distance, and its horizontal angles. Dili para sa ubang method sa leveling na ang compute lang nato isa katong difference in elevations or the elevations of the unknown points. So stadia and tacheometry is called the most precise methods of leveling. It is based on the methods of trigonometric leveling and three-wire leveling. So what are the uses of Stadia? We have the use for the preparation of topographic maps, detailed maps, siyempre, checking of already measured distances, and determine differences of elevation between points and reconnaissance surveys for highways, railways, etc., and establishing secondary control points. So actually, the word stadia is the plural of stadium. No, it comes from the Greek words for unit of length, which applied in measuring distances for athletic contests. So it's denoted by 600 Greek units or 184 meters, 93 centimeters by present-day international standards. Actually, the term stadia is now applied to the crosshairs and rod used in making measurements. So when we say stadia, it's only based on two surveying instrument. So dapat na siya crosshairs and a stadia rod. So mo lang siyang different sa ubang differential method. So ito lang 'yun. So dapat ang instrument mo is na ay telescope with stadia crosshair. So it must be equally distant from the horizontal hair and so position such that the one is found above and the other below. So we have the upper stadia and lower stadia. So we have these different kinds of stadia here or telescope sites. So dapat na siya yung mga stadia above and below. Kini ang mga tinatawag na crosshair. Okay? So the crosshair. So this is the pinaka-common na telescope na makita. So we have the upper and the lower and of course the middle reading. So kung makita ninyo ang upper reading and lower reading, so I think ang lower reading is nasa 7. Then ang middle reading is or the rod reading na ginatawag is 7. Di ko alam kung centimeter na yun or by meters or by feet or by inch. Since wala man nakalagay na units, no? 7.34. Di na ako siya masabtan ang iyang gradation, no? Masayang ana siya makita sa through telescope. Okay. Then of course we have the main instrument, the transit, the theodolite, and the total station. So mo na ang pinaka old or almost obsolete na siya na ginagamit, no, na instrument sa surveying. Then we have the theodolite and pinaka latest is the total station. So digital na. Isa ka click lang na nandito dahil ang coordinates, ang vertical angle, horizontal angle, and elevation sa point. So makita na siya. So katong mga gina-compute nato using differential level notes, no need na siya uh, imuon. Diretso na dire kung mao ni ang gamiton total stations. mugawas na dayon ang result. Isa lang ka site, ting! In a seconds na anay result dayon. So, no rin na ka mag-compute. So, once mako-obtain nimo ang data, diretso na ka-plot. Makabuhat na ka dayon og map or topographic maps. Okay? So, kini na mga instrument is naa sila yung mga crosshair na gitawag. Kung yun ani. Okay, so other instrument, we have the Stadia rods. So, these are the Stadia rods which are usually graduated in decimal of a foot but may be graduated in decimals of a meter or a yard. As aid in distinguishing the numbers and graduations, different colors are used. So, kung ito ay by meter, I think so na siya color-coded, no? Isa is every meter yellow, then another meter is white na, then another meter is yellow again. Para pag sight nimo kay minsan lagyo magud na ang sighting sa ano pag sight nimo sa telescope, dili nimo siya basta-basta makita. So maong na siya mga uh, different colors or gradation na ginatawag. So ang uban ang ani po ang iyang itsura. So dahil sila design po, no. So mao na ang ginatan-aw o silip sa kada points or station, no. Then ginakuha ang reading sa backside and foresight. So dapat kuan jud ang imong mata. Very clear. So actually mao lang siya ang kaibahan sa Stadia. It's sa instrument lang na ginagamit. So in methods of tacheometry, there are two methods. We have the Stadia system and the tangential system. So ang term na ginagamit is of course the Stadia system, which is based on the principle that in similar triangles, corresponding sides are proportional. So these are the standard symbols used in Stadia measurements. So we have the Stadia hairs are shown on points A and B. So these are the Stadia hairs. So when you sight on the telescope on the instrument, so the distance between the hairs is called I. Medyo blurred lang, no? Hindi kayo makaklaro. So ito yun, ito yung I. So for this particular setup, the line of sight of telescope is horizontal and the Stadia rod is held vertical at the distant point. So it is set up on horizontal line. So the apparent locations of the Stadia hairs on the rods are points A and B. So this is the point A and this is the point B. No? And the Stadia interval is S. So this is denoted as S. So this is the Stadia interval between the rod reading at points A and B, or the difference between A and B. So these are the lights from points A and B passing through the lens center. So this is the lens center from a pair of similar triangles A and B and A and B. So this is A and B. So this is center. So this is the similar triangles. Since AB is equal to A prime B prime, so by similar triangles, so F is to I is equal to D is to S. So Fi is also equal to the ratio of D to S. So F is I. So I is equal to S is the S, and the distance is equal to the ratio. It's also equal to the value of F. So for horizontal setup of a Stadia, so we can compute for the value of horizontal distance D, which is equals to D plus F plus C. Or we know that D is equal to Fi multiplied by S. So you can simplify the equation plus C. Or F over I is also known as K times S plus C. So in any horizontal setup of Stadia, so we can compute for the horizontal distance, it's equal to Ks plus C. So where K is the Stadia interval factor, so usually nag-range lang siya to 100 or 99.99, mga ana. Then the S is the Stadia or rad intercept, so it is the difference between the upper Stadia reading and the lower Stadia reading, A and B. And C is the Stadia constant. So, or the distance from the center of the instrument to the principal focus. So, usually, galing siya sa given siya sa manufacturer sa instrument, no? Ana siya constant per may iyahang value. So, the ratio Fi is called the Stadia internal factor and designated by the letter K. So, by the way, kining F1 is the image distance or length from the center of the objective lens to the plane of the cross wires, okay, when the telescope is focused on some definite points, while F2 is the object distance or length from the center of the objective lens to the definite point when the telescope is focused on that point, okay. I is distance or spacing between stadia hairs, same with S. So, by the way, the Stadia integral factor instrument with adjustable Stadia hair can easily be made 100 or any other desired value by moving the hairs until the rod interval is 1 over 100 of the distance from the principal focus to the rod. So, kung di ay sa middle reading or sa end yung tawag, that is called the rod reading. So, from previous formula ganina, Ks plus C, nasa'y constant. The Stadia constant. Okay. So, for Stadia methods on inclined sights, so we have the following formula. So, this is one of the advantage of the Stadia and tacheometry. So, we can incline the focus or the instrument, no, the telescope. So, pwede siya makuha reading maski dili lang siya horizontal. So, for the formula for the horizontal distance, using trigonometric method, so we obtain this value of the formula which is equal to Ks times cosine squared theta plus C times cosine theta. So, naana siya angle. So, the theta is in the angle between the horizontal side or horizontal level. And we can compute for the vertical distance. So, this is the vertical distance from the rod reading. So, ang rod reading is katong sa center reading from the telescope. So, that is equal to 1/2 the K, Stadia interval factor, times S times sine 2 theta plus Cx sine theta. Okay, so by trigonometric functions, so we arrive at these two equations kung inclined sights. So kung horizontal, that's only H is equal to K times S plus C. So mura siya. Wala na tong mga angle-angle. Ks plus C. Wala na cosine theta. Okay? So, Stadia constant is equal to 0, internal focusing telescope. So, C is equal to 1 feet, external focusing telescope. Okay, so we have here some example. So, the elevation of BM10 is 42.852 meters. The Stadia interval factor is 100 and C is 0. So determine the elevation of BM11 and record notes and elevations in a proper note form from the given Stadia level notes below. Okay. So, transfer na ako sa Excel ang notes. Okay. So, we have here the backside. We'll compute for the vertical and the elevations of BM11. So, the problem doesn't specify to compute the horizontal distance. So, disregard na lang nato ito, no? Okay, so this is the needed data. We will also compute the rod reading. So, magamit nato siya later. Rod reading. Okay. So, the elevation of BM10 is given as 42.852 meters. So, this in meters. Okay. First, we will compute the value of V, or the vertical distance. So, from BM10. So, the formula V is equal to 1 half Ks sine 2 theta. Ks sine 2 theta plus C x sine theta. But take note that the value of C is equal to 0. So, disregard na to on this part. So, B is equal to 1 half Ks times sine 2 theta. Okay, for BM10, so 1 half times K of 100 times S of Stadia interval 1.241 times sine of 2 theta. The theta is 4 degree. Ibutan na to ang negative sign. 4 degree, 24 minutes. So, the value is negative 9.49 meters. So, butang ninyo ang value sa ang sign. Okay. Then, for TP1, so 1 half times K of 100 times S of 2.041 times sine of 2 theta. The angle is 3 degree, 23 minutes, 12.02. Okay, for TP2, 1 half times 100 times 1.721 times sine of 2 theta of negative times 6 degree 30 minutes, negative 13.35. Wait, so mali. Negative 19.35. Kindly double check. Okay, for BM11, TP3. TP3, negative 10 units equals sine times S of 2.41 times 100 times negative 41.72 meters. Okay, so next it is foresight reading. Let's compute the v, or the vertical distance. So we have 0.5 times 100 times S of 1.506 times sine to, what is the theta, 8 degrees 10 minutes. Nag-error ko. Is 21.23. Okay, for TP2, the V is negative 7.68. TP3, that is 15.59. And BM11 is 9.95. Okay. Okay, I have some corrections. So this is 21.18, negative 7.69. Then we have 15.6. Kindly double check, no, notations. Okay, so now we compute for the HI, or the height of elevation. So take note. So the sign for the V, or the vertical distance on the rod reading for backside, so we will all change the sign. Now once we compute, we will change the sign, and then all the rod reading on the backside will be added, and all the rod reading on the foresight will be deducted. So from here, 42.852, so change the sign, so plus 9.49, so 42.852 plus 9.49, so plus 2.41, so the HI is 54.752. Okay, for the elevation of TP1, so we'll add 21.18 minus 1.52, that is 74.412. So HI for the TP1, 74.412. Change the sign, so minus 12.002 plus 1.05, 63.442. Then minus 7.69 minus 3.05, so that is 52.702. Then the HI of TP2, 52.72 plus 19.35 plus 1.45 equals to 73.502. Then the elevation of TP3, so plus 15.6 minus 0.24, that is 88.862. Then HI of TP3 minus, so plus 41.72 plus 2.04, 132.622. Elevation of BM11 is plus 9.95 minus 1.43, 141.142. meters. Kindly double check. So if you will try to plot, BM10. So let's say this is the benchmark 10. So we have a reading of 1.241 Stadia interval, then the rad reading of 2.41. So 1, 1, 2. Let's say this is the 2.41. Okay. So this is the horizontal line of sight. That's so we have an angle here of negative. So ibig sabihin pababa siya, no? The 4.24. So atong ma-compute na vertical distance diya is sa backside. So this is the BB. And then we have the rad reading of 2.41. So this is the 2.41. So this has an elevation of 42.852 meters. Okay. Then we have the foresight of 1.06. So, and an 8 degrees 10 minutes. So, pataas siya, no? Let's say division apart. So, 8. So, let's say, ano lang, 8 degrees 10 minutes. So, this is the BB. Okay. And the rad reading of 1.52 meters. Okay, naimali sa atong diagram. So we have a V of 1.21.18. So mali din itong sulat dire. So mali atong diagram. So most probably paano siya. So this is the BB, no? That is 21.18. Then we have the rad reading of 1.52. Okay, so So, tama siya na 42.852. Okay. So, we will add the vertical distance from the backside, that is equals to 9.49, and the rod reading of 2.41. So we'll get the elevation or the height of the instrument of 54.7 54.752. Then we will add the vertical distance. So this is the height of the instrument plus 21.18, and we will minus the 1.22 rod reading, so we can compute for the bench the elevation of TP1. So this is TP1 equals to 74.412 meters. So yung ana siya, yung setup. Then TP1 to TP2, I think pababa na siya, no? Okay, from back side of TP1, 3 degrees. So itong setup na dire is pababa na. Okay, positive man na itong angle. Sa mga ana siguro, 3.23. Then ang isa is negative na sad. So from frontal angle, nagbababa ta og 3.05. So paana na siya. Okay. Then TP2, TP3, negative 10 ang iyang backside. So sabot pababa ang instrument, negative. Ayan. So line is negative. Ana siguro, then sa is 10.08. Pataas na siya. Ana. So ato ay ano na ang setup, no? Okay. Okay, for arithmetic check, so the difference in elevation of the known to the unknown, so check equals to BM11 elevation minus BM10 elevation, 98.29. So should equal to the summation of the sum of the vertical distance to the rod reading of the backside to the foresight. So change sign, so that is equals to 58.54 plus 6.95 plus 39.04 minus 6.24. So we know that the rod reading of the foresight will be deducted and the backside will be added. So nag-equal sila, so meaning tama to ang computation. So muna ang arithmetic check. Okay. Okay, so next meeting we will again discuss additional sample problems for Stadia.